Good morning to all. Today's class we are going to see about 4-point FFT using DIT algorithms. So we are going to see about two algorithms. One is a decimation in time and another one is a decimation in frequency algorithm. So today class we are going to take this decimation in time. So decimate means dividing. So the frequency domain signals will be taken as an output and time domain signal that will be decimated. That's why it is taken as a decimation in time. So decimate the time domain signal, that's the meaning for this DIT. So how we are going to compute means, so the entire FFT values, there is a DFT, that will be a fast Fourier transform, we are performing it. So the computation of 4-point DFT that will be done by two 2-point DFTs and combining this result to produce a final output. Similarly, if you take an 8-point DFT, so what we do means, so we divide this 8-point DFT into two 4-point DFTs and then the results will be combined. Similarly, that 4-point again that will be divided into two points and results will be combined. So we take from 2-point DFT, we combine these two and to get a 4-point. Again another 4-point, we combine this result to produce a final 8-point DFTs. So why we go for this FFT means number of complex multiplications and additions will be very much reduced. So that's why we prefer to use this FFTs. The result of discrete Fourier transform and fast Fourier transform will be same. Similarly, if we use the decimation in time algorithm or decimation in frequency algorithm, both results will be same only. Look at this. So we are taking a problem. Find the DFT of the sequence x of n equal to 1, 1, 0, 0. So we can do this DFT using normal method, or here we are going to use decimation in time. If they mention using DIT algorithm, we need to use only this method. If they are not mentioned any methods, you can use any methods. So this will be very easy to compute it. So here they have not mentioned decimation in time algorithm. Still we are going to practice this decimation in time algorithm to save the time. Because if we go with a normal method, it takes lot of time. So if we go with this algorithm, so shortly we can compute the results and we get a final output. Look at this. We need to take this inputs 1, 0, 0, 0. So this is an input signal and then we need to performing it. So before feeding that input, we need to perform a bit reversal operation. So bit reversal is, so we know the binary equivalent for the each bits. So this is the 0 sample, first sample, second sample and third sample. So 0 we take it as a binary value as 0, 0. 1 we take a 0, 1 and 0. There is the second value that will be 1, 0 and 1, 1. This is the binary equivalent. Once if you reverse it, the MSB bit go for a LSB bit and LSB bit go for an MSB bit. So what happens actually, so for the first sample 0, so the binary equivalent is 0, 0. If you reverse also, you get the same 0, 0. Look at this second sample. So 0, 1 will be in second sample. So 0, 1, if you reverse it, you get a 1, 0. And third one, it is a 1, 0. So reverse it, you get a 0, 1. Similarly, last one, this will be 1, 1. If you reverse it, you get the same samples. So we have already learned that bit reversal. So this is for 2-bit bit reversals. So if you reorder it, what we get means, this is then 0 sample, this is second sample, this is first sample and this is third sample. So if you reorder it, so this is the 1, 0, then you need to write this 1 and you need to write this 0. Look at this 1, 0, 1, 0. So these input will be fed for the DFTs. Look at this. This is an actually decimation in time. We are dividing this. Look at this. This is a butterfly 1 butterfly. So this is butterfly 2. Here also we have butterfly 1 and this one. So we have a 2 stages. Each stage we have a 2 butterflies. Look at this first butterfly. The inputs will be, this is 1 and this is 0. So this 1 and this 0 will be given. And then tiddle factor. So we need to call it 2 tiddle factors. So this is the W04. Here also W04 because this is a 1-point DFT. Look at this. So here we need to take two things. There is a W04 and W24. So this is W04 and this is W24. So this value will be an tiddle factors. We need to multiply this. So how to compute? I'll explain this. Look at this butterfly alone. We have two inputs 1 and 0. So this will be fed here. We need to compute for results for this uplift and downlift. So uplift nothing needed. So first thing we need to take this input and that should be multiplied with this tiddle factor. After multiplication, this value should be added for this. Look at this. So this value is 1. We directly I am taking this. and this 0 and this 1, that is the second, this input, and it will be multiplied with the tittle factor. So 0 into 1 is multiplied. After multiplication results, that should be combined with this another input. That's why I am putting a bracket here. So 0 into 1 will be 0. So that will be added with 1, you get a 1 here. Look at this. So for down leaf, we need to perform subtraction. Look at this. Take the first input, directly we can take this, and 0 and 1 should be multiplied. So after multiplication result, that should be subtracted from the first sample. Look at this. 1 minus 0 into 1. So that will be 1 minus 0. Again we get 1 here. The same thing that will be done for this second butterfly also. So one input is 1, another input also 0, and the tittle factor is 1. So 1 into 0 will be 0. So this 0 should be added for this and subtracted for this. So 1 plus 0 is 1. 1 minus 0 is 1 here. Look at this second stage. Second stage also we have 2 butterflies, but the input and tittle factor is different. Look at this. For this green butterfly, look at this. One input is 1 and another input is 1, and tittle factor is 1. So we need to multiply these two values. This 1 and this 1 is multiplied. After multiplication, this value should be added for this up leaf, and that should be subtracted for down leaf. So one input is 1. This multiplication result is 1. So 1 plus 1 is 2. Look at this. 1 plus 1 into 1 is we are multiplying the tittle factor on the second input. So this is also 1. So 1 plus 1 will be 2. Look at this down leaf. You should not consider this value. You need to consider this third one, because this leaf connects here only. So x of 2, that will be equal to, so this 1 into 1 will be 1. 1 minus of 1 into 1. So look at this. 1 minus of 1 into 1. So 1 minus 1, that will be equal to 0. Look at this fourth butterfly. So one input is 1 and another one input is 1, and the tittle factor is minus j. So this minus j should be multiplied with 1. So 1 into minus j is minus j. That should be added for this up leaf, and that should be subtracted for down leaf. So 1 is a 1 input. If we add it, what you get? So 1 plus minus j. Look at this. 1 plus 1 into minus j. So that is 1 into minus j will be equal to minus j. So you get a final answer as 1 minus j. Look at this for down leaf. So here we have the 1, and here we have this minus j. So 1 minus of 1 into minus j. So if you multiply with this minus 1 into minus j, that becomes a plus j. So 1 plus j. So the given input is x of n equal to 1, 1, 0, 0. X of k equal to 2, 1 minus j, 0, 1 plus j. So this is the frequency domain converted output.